Okay, so in this week's Edpuzzle, we're going to be taking a look at a concept called piecewise functions. When you take a look at the right-hand side of a piecewise function, you're going to see that there are kind of restrictions in terms of it's going to look like the graph of 2x minus 3 if x is less than 2. And it's going to look like the graph h of x equals 3 if x is greater than or equal to 2. So you can see that this is a piecewise function that has two parts that is split along the line of all of the x values less than 2 or greater than 2. So what I'm going to do right now to help myself out is I'm going to kind of draw a vertical line down at x equals 2 as best as I can, because this helps me this lets me know that this is kind of, I'm going to have one picture on the left-hand side. So on the left-hand side, it should look like the graph of 2x minus 3. And so on this side, it should look like the graph of 2x minus 3. And over on that right-hand side should look like the graph of, so this is y is equal to 2x minus 3, and this is going to be y is equal to 3. So let's first take a look at this first piece, which is 2x minus 3. So 2x minus 3, that's our y values, right? Let me clean this up a little bit. So our y values, we're going to create a table here. Y values are 2x minus 3. And then we're going to have our x values, which we just need to know our x values are less than 2. So let's pick some x values that are less than 2. Well, 0 is an x value that's less than 2, and so is negative 1. And if I plug 0 in here, I get y is equal to 2 times 0 minus 3, which is negative 3. So we know the point 0, negative 3 is on this graph. If we plug negative 1 in, 2 times negative 1 minus 3 is negative 2 minus 3, which is negative 5. So we've got these 2 points. Now there's one more point I want to do, and I want to find out what's going on. I'm going to use a different color for this. What's going on right at that edge? So right at the end point where this graph is going to line up, which is 2. And if I plug 2 in, I get 2 times 2 minus 3, which is 4 minus 3, which is 1. So I know I also have the point 2, 1. Now, what's going to happen here, though, is this gets an open circle. Why is that? That's because this is for the x values less than 2. Since it's just the x values less than 2, it gets an open circle. If that was less than or equal to, we would give that one a closed circle. So let's go ahead and finish by drawing this line. So this is what the left-hand side of this piecewise function is going to look like. It's going to be the graph of 2x minus 3. It's just everything up to that vertical line, x equals 2. Now for y equals 3, this one's going to be a little bit more straightforward. So I've got some x values, and we know these x values are greater than or equal to 2. And no matter what, our y value is going to be equal to 3. So a couple values that are greater than or equal to 2, I could pick 3 and 4. And guess what? We don't have an x to plug into over there. So the y value is going to stay 3. So it's going to be 3, 3, 4, 3, all the way. So everything over here. Now we want to make sure we figure out what's going on this line. So again, if at 2, the y value is also 3. But this one gets a closed circle. And why does it get a closed circle? That's because it goes right up to 3. And since it's or equal to, it gets a closed circle. So we've got this graph. So we've graphed the function. There it is right there. There's my piecewise function. It says find the domain. Remember, domain are the x values. So as I go left to right, I know that my domain is going to start out here at negative infinity, because this arrow right here tells me that it's going to be going to the left forever. And I follow along. Even though I have an open circle right here, the graph jumps up right here and heads to the right forever. So this domain is going to be from negative infinity to infinity. Now the range is a little bit more complicated because range, remember, is the y values. So when we take a look at the y values here, we're going to go down to up. So starting down here, we can see that this graph lets us know that it's going to be going down forever. So it's going to be from negative infinity all the way up to, you can see that I have an open circle right here at 2. It's never, or I'm sorry, at 1, at y equals 1. It's never going to actually be equal to 1 because that has a rounded circle. But we need to be careful here because there also is another y value right here. We can see that we also have a y value at 3. So we need to add another piece to this range. So the range is going to be from negative infinity to 1, not including 1, so we put a rounded bracket. And it's also have a y value at 3. The last thing that this is asking for is it's asking for the intercepts. So let's locate the intercepts. Well, there's an x-intercepts. So let's see, where does this graph cross the x-axis? It's right here, right? So we have an x-intercept at the point 1, 0. And now we'll also look for a y-intercept. Can you see where this graph crosses the y-axis? We also plotted that point. So we also have a y-intercept at 0, -3. Be careful there. I was very tempted to write that -3 first. That point is actually 0, -3.